So this is a review of honors chemistry. We will be talking about KW and pH. And I will go fairly quickly on this one because we're just only reviewing. So we're looking at water, and water will auto-ionize. That means on its own, if you have H2O, automatically on its own, it will ionize into H plus and OH minus. Okay, so let me show you that on the Lewis structure of water, HOH. So as you can see, this H can come off and become H plus, and the OH will come off and become the hydroxide. Okay, one more thing, this H plus does not exist alone in water. What it will do is it will attach to another water molecule right on top of it, becoming H3O plus, which is called the hydronium ion that we talked about later. So what you will see in all the textbooks and when I'm lecturing is that H3O plus is the same thing as H plus. Okay? We write H plus to be more efficient, but we really mean H3O plus. So when you're looking at the pH, sometimes they say pH of H equals negative log of H3O plus, or pH equals negative log of H plus, the same thing. Okay, so water's amphoteric. That means it can be both an acid as it gives the H plus and a base as it gives the OH minus. This is just water. They're putting two waters together, which is a little bit confusing, but really they're reacting with each other. So here's water, and the conjugate pair is this. And here's the other water, and the conjugate pair is this. So in these two, this is the acid and this is the base. And here you have, this is the acid because it has more H's, and this is the base. So here you're just acting, water can be both an acid and a base. Okay, this breaking up is called auto-ionization, as it breaks up into these two pieces. So all these equations are the same thing. So the ion product constant is, as you can see, the ions H3O plus or H plus and OH minus are multiplied. Product to get the product, and it's also constant. Okay, so what this means is if you look at the K equilibrium expression here, this is Ka. Since it's also water, sometimes they use Kw. So all the same thing. Okay, so I'm sorry, not Ka, just Kw, because it has an acid and a base. So the expression would be H3O plus times OH minus. Or Kw can be written as H plus and OH minus. And again, since it's for water, they put the W. And they don't put the waters here in the bottom, the products, because they're liquid, so you don't include liquids in the expression. So this is just a formula for Kw. The answer you get here at 25 degrees Celsius is 1e negative 14. This is called the ion product constant, and it's called Kw. Okay, so it says calculate the values of H plus and OH minus in a neutral solution. In a neutral solution, Kw is equal to H plus times OH minus. This is 1e negative 14 is equal to, we can just say x squared. So x is equal to 1e negative 7. So this is the molarity of both H plus and also the molarity of OH minus. So as you can see, the molarity are equal to each other, which makes them neutral. So if you take the log of this substance, negative log of 1e negative 7, you will get the pH of 7, which is the pH of a neutral solution. Okay? So here, you watched a video on the pH scale. At 7, you have the, it's going to be neutral. If This is 10 to the negative 9, which is less than 10 to the negative 7, so this will be basic. This is, again, 10 to the negative 9. That's the same thing. It will be basic again. This one, this is the OH minus, which means you have to calculate for the H plus to see if it's acidic, basic, or neutral. So Kw is equal to H plus times OH minus. 1e negative 14 is equal to, you're looking for the H plus. Plug in the OH minus here, 7e negative 13, and you will find the H plus concentration. So when I calculated this, I got 0.01 molar of the H plus, and you compare, this is the amount of H plus, and this is the amount of OH minus. You obviously have more H pluses, so this would be acidic. I believe B should, this might be a 7 because it's a typo, so that's one's neutral. Be a 1e negative 7, it's neutral. Okay, so let's try this one. Go ahead and read it and pause the video and do it. So it says calculate the concentration of H plus in a solution in which OH minus is this. So I use the equation Kw equals H plus times OH minus. I plugged in Kw as 1e negative 14 at 25 degrees Celsius. And if the temperature changes, they will give you a new Kw. Okay, it's constant at that temperature. And then OH minus is 0.01, solve for X, which is that, and it's molar of H plus, and this is how you report your answer. Okay, next, do the same thing here. 1e negative 14, X is missing, this is 1.8e negative 9 now, so this is the H plus. If you were to try to figure out which one's acidic, if this is acidic or basic solution, you compare the OH minus, which is a lot bigger than the H plus, so this will be a basic solution. Here you have E negative 9, this is E negative 6, this is bigger, so it will be acidic. Okay, so the pH is defined as negative base 10 log of the concentration, which is that formula. In pure water, they're H plus, Kw equals H plus times OH minus equals 1e negative 14. In pure water, they're equal to each other. Take the square root, so it'll be pH 7. Okay, and note that H3O plus is the same as H plus. If you have, in pure water, you have 1e negative 7 of the H plus, so it'll be pH 7. The acid has a lot of H3O pluses or H plus, same thing. So its pH will be less than 7. And if you have very low H3O pluses, it'll be above 7. So this will be acidic, below 7, and this will be basic. Again, please watch the video that I gave you as a review from Honors Chemistry. It's better than this. Okay, it'll give you a better understanding. So 16.6, I just want to do briefly. If you want to get the pH, just plug it into the formula. pH is equal to negative log of the H plus. And that's what I did here. Okay. Here, if they gave you the H plus, or they want the H plus instead, you have these two formulas. The opposite of the log is the anti-log, which is this. So if they gave you the pH of 3.76 and they want you to get the H plus, you have to use this formula. So the H plus will be equal to 10 to the negative of the pH, which is 3.76. And you just calculate that to be 1.7 E negative 4. And would be molarity of H plus. And again, the significant figures. This has 2 sig figs, and this has 2 sig figs here. Okay, we have other P scales. You can do P equals negative, P of X, whatever it is negative log of X. So if it's pOH, then it's negative log of the OH. If it's pKW, then it's negative log of the KW. And KW is 1e negative 14, so pKW is 14. So you can already see that pH plus pOH is equal to pKW. If this is 7, then the pKW is equal to 14. You're at neutral, and so on. So they add up to 14. So how do we measure pH? I think chemically you should understand what's happening to the molecule. This is a very popular indicator, phenolphthalein. Okay, phenolphthalein looks like this if it's neutral or if it's acidic. And let me show you why that is, okay? So phenolphthalein looks like this. The molecule is this. This is the H. When the H is bonded to this O right here on phenolphthalein, it has no color. So if you keep adding H pluses to this, drops of H pluses, it'll attach to there and it'll be no color, colorless. So if it has a lot of H pluses, then pH 2, pH 3, 4, 5, 6 will be colorless. Yes, colorless. Okay. Now, if you add a base to this, OH minus, what's going to happen is the OH minus will extract the H, pulling it away. And as you can see here, the electron moves here, 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 here. It makes a double bond here that wasn't there before. So the structure of the molecule changes. Since the electrons move, you also have a different absorbance of light, and it gives off or emits a different wavelength of light, giving it a different color. So it is a change in the conformation of the molecule, which causes a change in position of the electrons, which gives it a different absorbance and emits a different color. Okay, so now it turns pink. So if you add base to this, OH minus, it turns pink. So anything above 7, it'll turn pink. So 8, 9, 10, 11. Actually, this changes pH a little bit above, changes color a little bit above 7. Okay. So this formula, it just shows you this IN is short for this big molecule because we don't want to give you the chemical structure. It's too long. If the H is attached to this chemical structure, it is clear. If you remove the H, it turns pink. This is with no H. This molecule, which is this, is pink. Okay. We can also measure pH using a pH meter. The pH meter uses an changes the number of ions in their H plus, Cl minus, to an electrical signal, gives a different voltage, which then gives you the pH reading. This one is 2.27.